Prior to answering our associated grades query, let's explore into the world of differentiation. Instead of me explaining, let's find someone to explain this differentiation. Let's go!
Do you want me to explain?
Yes!
Let's dive right in, shall we?
So, what is differentiation? Differentiation is the process of finding the derivative of a function. The derivative represents the rate at which a function changes with respect to its independent variable. It provides information about the slope or gradient of the function at each point. So, why do we use differentiation? To determine the maximum and minimum values of specific function. It is also employed when calculating the speed or distance of moving objects. The rate of change of a function, defined as dy over dx equals fx equals y. There are several applications of differentiation that we have learned, including related rates, apply maximum and minimum problems, analysis of function 1, determining increase, decrease, and concavity, analysis of function 2, identify relative extrema and using the first and second derivative test, Rolle's theorem and mean value theorem. Before we proceed to the question, let us first understand what related rates are. Related rates refer to the rates of change associated with two or more related quantities that are changing over time. This typically involves establishing an equation that connects the two variables and subsequently differentiating the equation with respect to time. The procedure involves two steps. First, determining an equation that relates the two quantities. Secondly, applying the chain rule or the implicit differentiation method.
This is the problem statement. A rocket is launched vertically into the air. Its height h above the ground at time t is given by the equation ht equals to negative 5t power of 2 plus 20t, where ht represents the height in meters and t represents time in seconds. Find the maximum height reached by the rocket and the time it takes to reach that height. So now we are going to show you the steps of the solution for the problem statement.
So firstly, we need to find the derivatives of ht, which is this equation. So plus 20, we get negative 10 plus 20. So this is the first step. So for the second step, let dh over dt equals to 0. So the answer for dht is negative 10t plus 20 equals to 0. 20, 20. So the answer is 2 seconds.
Okay, so for the step 3, to determine if the critical point is maximum or minimum value, we need to do the second derivative test. Okay, so the formula is t to h over t squared. So we need to know the second derivative test. Okay, so from here, this is first derivative test. So we do the second derivative test. Equals to h over t squared equals to negative 10t equals to negative 10. Okay, so this is the value for the second derivative test. Okay, so if the second derivative test is below than 0, it means the value is the maximum value. But if the second derivative test is more than 0, it means the value is the minimum value. So when we look at this second derivative test, it's a negative 0, means it's below than 0. So we can conclude that t equals to 2 seconds is the maximum value. Okay, so to find the high maximum value, we need to substitute the t value into the high equation. So when t equals to 2, we need to find the h. So
H2 equals to negative 5 2 squared plus 22. So we calculate this and we get 20. So the height value is 20 meters. Okay, reach 20 meters of height and it takes 2 seconds to reach that height. So this question demonstrates the application of differentiation such as critical points and decimal and middle value using first derivatives and second derivatives. That's all. Remember, when we are beneath, dare to look up to create expressions. But when we are already above, also glance down to recognize where we come from.